So welcome back, learners. We're also going to learn about this concept on mole concept, and this is a very common question both in chemistry paper 1, chemistry paper 2, and even chemistry practical. So we are going to handle this question, which talks about, in a filtration experiment, 25 cubic centimeters of sodium hydroxide containing 8 grams per liter was required for complete neutralization of 0.245 grams of a diabatic acid. Then you are told, calculate the relative molecular mass of the acid. Then you're told sodium is equals to 23, oxygen is equals to 16, hydrogen is equals to 1. So once more, if you're watching our channel for the first time, kindly take time, subscribe, like, and share. You can also share the video with your colleagues and also link from other schools so that they can subscribe. First and foremost, this question, when you meet it, I've started by writing this equation here. Because remember, this is sodium hydroxide and a diabatic acid. A diabatic acid means it has two hydrogens. We have monobasic, we have diabatic, and we have triabatic. So when we talk about monobasic, ni kama hydrochloric acid, iko na hydrogen moja, H. Diabasic ni kama sulfuric acid, it has two hydrogens. So I've tried to write this equation here where we have sodium hydroxide, and this is my example of a diabatic acid. Now this 2 means that the X is the one that has 2. So when I write the equation, the 2 ya X itakuja hapa chini. And if for me to balance this equation, because already I have 2 sodiums on this side, I'm also going to ensure that my number of sodiums on this other side also becomes what? 2. I'm going to ensure that I also have 2 sodiums on this other side. And how do I ensure that I have 2 sodiums on this other side? There are several ways I'm going to do that. I can come here, and then for me to balance my equation, I'll write here that now I have 2 sodiums. And you remember that when I write 2 here, hydrogens on this side becomes 4. So that means here I must also make my number of hydrogen, I must also write here 2, so that 2 times 2 will be able to make hydrogen 4 on this side. Now let us go directly into solving this question. Now if you are solving this question, you must be able to ask yourself, where you're asked, you have sodium hydroxide. Now this sodium hydroxide, you look at the information that you've been provided with about sodium hydroxide. You've been provided with the volume and the grams per liter, which is 8 grams per liter. So you have to note those informations down here. You're going to ensure that the information that you've been provided with about sodium hydroxide, you ensure below sodium hydroxide, you note those informations down here. So the information you've been provided about sodium hydroxide is the volume. You've been provided with the volume, and your volume in this case is 25 centimeters cubic. The second information you've been provided about sodium hydroxide is something which is called grams per liter. Grams per liter. And your grams per liter in this case is equals to 8 grams per liter. 8 grams per liter. That is very important. So once you get that you have the volume and the grams per liter, with the volume and the grams per liter, using this information that you've been provided with down here, you can also get the RFM of sodium hydroxide. That means you can also get the RFM of sodium hydroxide. The RFM of sodium hydroxide. And the RFM of sodium hydroxide in this case is going to be, you see, sodium is 23 and oxygen is 16 and hydrogen is 1. So if you add the 3, your RFM is going to be what? 40. Now, you also look at the information that you've been provided with about the diabatic acid. This diabatic acid, which information do I have about this diabatic acid? For the diabatic acid, whatever we've been provided with only is the mass that reacted of the diabatic acid. And the mass of the diabatic acid that reacted, was 0.245 grams. That is very important. Now, from there you must know for sodium hydroxide, because we have the grams per liter and we have the RFM, it means we can get something which is called what? Molarity. Molarity. Because there's a formula that says molarity is equals to grams per liter. Molarity is equals to grams per liter over the RFM. Over the RFM. So if you want to get molarity of any substance, use the grams per liter over the RFM. Now, we can now get our molarity. So for this case, our molarity is going to be equal to our grams per liter, which is 8 grams per liter, over our RFM, in this case, which is 40. 8 grams per liter divided by 40. So if you work out these learners, you're going to get that in this case, your molarity is going to be equal to, if you take 8 in your calculator, you divide it by 40, you'll get your molarity is going to be 0.2 molar. Remember, this is the molarity of sodium hydroxide. This is the molarity of sodium hydroxide. Because we have the molarity of sodium hydroxide, and remember, using the molarity of sodium hydroxide and this volume of sodium hydroxide, remember we have the molarity of sodium hydroxide and this volume of sodium hydroxide, it means we can get moles. Because anything molar is equivalent to a liter of a solution. So what about this volume that is up here? That is going to help us get the moles of sodium hydroxide. So we'll simply say this molarity, which is 0.2 molar, it is equivalent to 1,000 cubic centimeters. 1,000 centimeters cubic. So if it is equivalent to 1,000 cubic centimeters, then we say, what about the volume of sodium hydroxide in this experiment, which was 25 centimeters cubic? Which moles is it going to give us? So when we reach here, we simply cross multiply at this point. And when you cross multiply, you're going to realize, so you'll be multiplying 25 times 0.2, and then you divide by 1,000. 25 times 0.2, and then you divide by 1,000. If you work out that, you're going to get here that your number of moles, the number of moles is going to be equal to 0.005 moles. Remember, these are moles of sodium hydroxide. Very important. These are moles of sodium hydroxide. Now, because we have the moles of sodium hydroxide, we can get the moles of this diabasic acid using the mole ratio. Because if you look at sodium hydroxide and the diabasic acid, their mole ratio is 2 to 1. If you look in front of sodium hydroxide, kuna 2. In front of the diabasic acid, hakuna kitu. So it means the mole ratio of the diabasic acid to sodium hydroxide is 2 to 1. So that one you also note here. Sodium hydroxide to the diabasic acid. The mole ratio of sodium hydroxide to our diabasic acid, to the diabasic acid, diabasic acid is going to be equal to 2 to 1. So you note that here, the mole ratio is 2. The mole ratio is 2 to ratio 1. 2 to ratio 1. So here becomes 1. Now once you solve that, then you're going to realize, because the moles of sodium hydroxide already tumeshapata ni 0.005 moles. So for us to get the moles of the diabasic acid, we simply divide by 2. So the moles of the diabasic acid is going to be equal to 0.0025 moles. Because we have the moles of the diabasic acid, these are now the moles of the diabasic acid. Because we have the moles of the diabasic acid and we have the mass of the diabasic acid, these moles of diabasic acid are equivalent to this mass of diabasic acid. So our moles of diabasic acid is 0.0025 moles. Now those number of moles, they are equivalent to what mass? They are equivalent to this mass up here, which is 0.245 grams. Now if this moles is equivalent to these grams, and because you want the RFM, then you simply say, what about 1 mole? What about 1 mole? Then you simply cross multiply. When you cross multiply this, you are now going to be able to get something which we now call the RFM. The RFM. You're going to get the relative molecular mass. The relative molecular mass of the diabasic acid, which is also called RMM. So the RMM of the diabasic acid is going to be equal to, so you simply take from your calculator, you take 1, you multiply by 0.245, and then you divide by 0.0025. When you dissolve that, learners, you're going to get that now your relative molecular mass in this case is going to be equal to 98. That is now your relative molecular mass, and this can even be in grams, okay, but 98 is just okay. So I think up to there, learners, you've learned something on calculation of moles. That is very important. If you're watching our channel for the first time, kindly take time, subscribe, like and share. I'm also going to do this question down here in our subsequent video so that you get to understand these concepts very well. Thank you very much. God bless you.